So what we have here is that for the 7 days of the week, we have this distribution, that is 19.1% of the volume is on Mondays, 19.8% is on Tuesdays, and so on and so forth. And we have converted the percentages to the proportion. And what we want to do is this, that we want to see if the observed numbers, they go in the same proportion as this distribution. Okay, so what we are going to do is that we are going to use the chi-square statistic for this purpose. All right, and we have to make a test at 5% level of significance. So we will compute the chi-square statistics, and since we have 7 rows here, I mean on the top we just have the labels and we have 7 rows of data. So our degrees of freedom here would be how much? 7 minus 1, that is 6. Okay, so these are the observed numbers. Okay, now how do we compute the expected numbers? First we go ahead and get the sum of the observed numbers. How much that is? That is 414. Okay, let me make it back for you. Okay, so there are 414 of them. So these are the observed numbers, and here are the expected numbers. And how would I get them? Let me enlarge this size. Sorry. Okay. That is, so I'll put an equal sign, and the total is 414, and I want to multiply what? This proportion, so that we can get the expected number here. So expected number for this is 79.074, and we just bring the cursor here, and when we get the plus sign we can double click, and here we have all the expected numbers. Okay, now what do we need? We need the observed minus the expected. Let me increase the font size here again. Okay, so here you go. So we will have observed minus the expected. All right. So let's compute observed. Actually, remember this. What do we need here? In fact, I forgot the summation sign here. I'm so sorry. Okay. Yes, we need to add all these up. So we will have observed minus expected square divided by expected. So going back to Excel, why don't we go ahead and square this right here? Okay, so we have this, we got observed, then we have expected, then we square this quantity. All right, enter here. Okay, and there you go. So we got all the observed minus expected square. Okay, now what do we need? We need observed minus expected square divided by expected, right? Okay, so expected square and divided by the expected count. That's what we need here. Okay, so we will go ahead, and what we are going to do now is, this is my observed minus expected square, and I want to divide it by the expected count. So here is the number, and we get them all here. And now when we add them all up, okay, so let's add them all up. All right, what we get? 12.37 as our chi-square statistic, right? Or our test statistic is how much here? Let me get that back. I forgot about it. Okay, so 12 minus 374. etc., etc. And the degrees of freedom is how much? The degrees of freedom is 6. Okay, so now we want to get the p-value, that what is the tail area after 12.34 at 6 degrees of freedom. And if you've gotten used to computing these, you know that the tail area will be very little. But let's go, and we have Excel here, so just click on any empty cell. Okay, and what you get is, go to chi-square in a statistical. All right. Okay, and oh, I went too far. Okay, so chi-square distribution, and we want the right tail here. How much is my x? X is right here, 12.37428. I think that much should do it approximately. My degrees of freedom is how much? My degrees of freedom is 6. Well, it's not really that tiny, okay, or that small. As I said, 3, because degrees of freedom here is not that large. Okay, so this is 384. Okay, so what we have is, we have the right tail of the chi-square distribution at the 6 degrees of freedom, and which is how much? That is your p-value is, or our p-value here is about the is 0.05412, which is not less than 0.05. So we are not going to reject the null hypothesis, and we'll say that from the data we are still keeping the null, that is the observed frequencies, and as that formulated in the question, they are proportional to the distribution shown. Okay, so we are going to work on the arithmetic portion of this exercise 9.15 in our textbook, the textbook that we are using.